All right, welcome everyone to our first Bevinar. We're streaming live from Ofheim, me, that's Stefan Meyering, and Jan Oertli, explaining the technical side of our first Bevinar, which is about carbonation and blending. So before we start, little rules about interaction. You can ask questions whenever you want. Very important for us, please provide your feedback after our webinar so we can improve and learn a little bit about the demands in the market a little bit more. All right, so there we go. Quick introduction. So you guys know that that's the key. Flat beer sucks, definitely. So this is just a quick picture from my favorite coffee mug and some sort of where I where we gained the idea from getting the Bevinar done. And so what's happening in the market out there? You guys know that your customers definitely would like to have carbonated beer and beers which are in spec. So what's the key thing about carbonation that nobody in the market as a customer expects any product, whether beer or carbonated soft drink, to be out of the global acceptance range. So that's given in the term drinkability, basically. So there's reasons for enjoyment from customer expectation, but there's also legal reasons, like you have to have your beverage being in a precise range of alcohol or original gravity or sugar content, as well as carbonation levels. So nobody would like to have any flat beer or carbonated soft drink, especially when it's packaged. So you got to make sure that everything is right before you start the packaging. There is also reasons for certain varieties. So if you see different beer styles, like wheat beer here in Germany, or the other big opposite of it, basically a Bamberg style called ungespundet, or any Pilsner beer, which has or lager beer, which has just a regular average level of carbonation. Next to those, sparkling drinks or lower carbonated medium mineral water. So there's a wide range, and some brewers, co-packagers have to apply that range to their technical equipment. Some other drinks, as mentioned, carbonated soft drink is one of them. So there is carbonation during the process of fermentation, but if there is no fermentation, you got to make sure that everything gets carbonated during the process. I'd now like to hand over to Jan, starting with the technical side.
Yeah, we will have a look at the technical side of carbonation and blending. First, about carbonation. So the question is, why do we need to carbonate a beer? As we all know, the beer gets its own CO2 during the fermentation from the yeast. And the brewer has also the possibility to adjust the content he wants in the beer by setting the head pressure in the tank. So the question is, why do we have to carbonate afterwards? One reason is, so when the beer leaves the storage tank, a couple of process steps will come. For example, a separator, filtration. So here the beer might lose some of its CO2. So it's good afterwards to adjust it to the original CO2 content. You could also say, okay, why I don't carbonate it a bit higher before these steps, but then you can never be completely sure what will be the final CO2 content. Another reason is if you go into blending the beer, this will also be a topic later, you blend with water, which has no CO2, and of course you have to add the CO2 because of the missing CO2 in the water you add. And finally, if you make carbonated soft drinks, they have no CO2, so you have to carbonate from 0 to whatever you want. I want to have a look Shortly on the physical details about carbonation, there are mainly two principles that we need, and every brewer knew the Henry's law. Perhaps you don't know the name, but that describes that to get a certain content of CO2 dissolved in the beer, you need a certain pressure depending on the temperature of the beer. This is normally what you have in a table, and you adjust the tank pressure, as I said, and you will end up with the CO2 content you need. This is also important when we go to inline carbonation, but here it's important to be above this pressure we need. So that's one point. The other point is we want to get CO2 solved very quickly. So we need to distribute the CO2 into the beer stream with very small bubbles. When the surface of the bubbles is bigger, the dissolving is much faster. The second we want to talk about today is the blending. There are two main points why we blend. One is the high gravity brewing. So we brew a beer with a much higher alcohol content, and we blend it down, and then from a, let's say, 100 barrel fermenter, we get out 110, 120, or even 150 barrels of beer. So we can expand our production capacities. The other point is the alcohol trimming. So as you all know, beer will end up in a bit different alcohol contents from batch to batch to ensure to have always the same alcohol content. You can brew a beer a bit higher and then just trim it with a small amount of water. And often many breweries have both beers, and so here the problem is you have a very wide range in the ratio of the water to the beer you want to. So here very important is to measure it very accurately and to blend a dose in a very wide range, very accurate. As I said, very important is to know what does the final beer has, and so we can control it. And for this we need inline measurement. And for this we have our partner from Anton Paar in Graz, who will tell something about the inline measurements. So I will hand over to Markus Freisinger in Graz, Austria.
Thank you, Jan. A very warm welcome from my side. My name is Markus Freisinger and I work for the company Anton Paar. In the next few minutes, I will give you a short introduction into the inline process measuring system, the so-called beverage monitor or beer monitor Cobrix from Anton Paar, which is integrated in the corosys blending and carbonating systems. The beverage monitor basically consists of two sensors, one sensor for extract and alcohol measurement and one sensor for CO2 measurement. First of all, I will give you an overview about the density and sound velocity sensor ELCOM for alcohol and extract measurement. The ELCOM is using a combination of an oscillating U-tube principle for density measurement and the propagation time of sound pulses for sound velocity measurement. On the bottom left corner, you can see the sensor inside. So you have the banded U-tube, which is, as I mentioned, for the density measurement, and a small module for sound velocity measurement, as well as temperature sensors for temperature compensation. Additionally, the sensor is also integrated with a sample pump to ensure proper flow through the sensor, as well as a pressure sensor for pressure compensation. The ELCOM is completely maintenance-free with a very short measuring interval of 1 second. The second part of the beverage monitor is the CO2 sensor. Anton Paar offers two different sensors. We call it Carbo. So we have the Carbo 510, which is based on a conventional pressure temperature method. And we have the Carbo 520, which is based on an optical measuring principle, which is called attenuated total reflection. The difference is the maintenance and the measuring interval. So Carbo 510 requires a maintenance once a year to exchange the membranes inside the sensor. The Carbo 520 is completely maintenance-free due to the optical measuring principle. The measuring interval of the Carbo 510 is 15 seconds. In comparison to that, the Carbo 520 has only a 4 seconds measuring interval. On the next slide, you can see a summary of the beverage monitor. As I said, it's always a combination of a CO2 sensor and the alcohol and extract sensor. We differentiate two beverage systems depending on which CO2 sensor is part of the system. So if the conventional temperature pressure sensor Carbo 510 is part of the Cobrix, we call it Cobrix 5500. And if the optical CO2 measurement is part of the Cobrix, we call it Cobrix 5600. Also, MPDS5 evaluation unit is part of the beverage monitor. The beverage monitor gets the raw values from the sensors. For example, from the Elcom, the MPDS gets the temperature, the density, and the sound velocity. And with these raw values, the evaluation unit calculates the measuring values like alcohol and extract and distributes it to the PLC. The beverage monitor is a system for all beverage applications, so you can use it for carbonated soft drinks, beer, or wine, for example. Depending on which product type you choose, you will get the required parameters. So for example, if you have a soft drink production and your product type is a soft drink, then the sensors will calculate the Brix value instead of the Plato value. You also can configure the system with an optional O2 sensor. And on my final table, you can see all specifications of the beverage monitor. As you can see, the beverage monitor really reaches highest accuracies of all parameters like Plato, alcohol, and CO2. Yeah, that's it from my side. I hand over back to Stefan and Jan. Thank you.
Yeah, thank you. We will go on with our technology of carbonation and blending. First, the main part of the carbonation is our gas injector GDI. As said, very important is to get the CO2 distributed in very fine bubbles into the beer stream to get them solved as fast as possible. And here you see an example just in the simulation. If you only bubble in by a T-piece or another injector, which makes bigger bubbles, or with our injector, you get very small bubbles from the beginning and get them solved after a quick times of just a couple of seconds. Our injector uses the Venturi principle, so there will be a slightly pressure drop inside the nozzle where the CO2 is distributed. But also very important is that the overall pressure drop over the injector is very small. You can see a graph here. It's just an example, as every injector will be designed and sized individually. And for example, you see the pressure graphs, it drops to the middle and then it comes back and the pressure is almost the same or slightly below the inlet pressure. So there's a small pressure drop. And you see here the solving of the CO2. So at 100% means you have reached the pressure you need to solve the CO2, and the pressure is already reached just at the outlet of the injector. So from this point on, we can start solving the small bubbles that we distributed into the beer stream. Some other important things are especially the hygienic design of the injector. So you have to ensure that you can clean it. There are not too many inserts, and we have a very straightforward design. Nothing inside the beer stream. And we will see it later in the overall system picture that it can be cleaned very easily and proper. Then when we have a look at the blending technology here, as I said, big point is that we can blend a very wide range from the alcohol trimming with a small amount of water up to the high gravity blending, sometimes from 14, 15, 16 plateau down to 10 or 11, which means you're almost half of the beer is water. This we can do with two different control valves, a bigger one and a smaller one. And here, not only the control valves are important, also the automation and the controls of these play a very important role for the accurate and very fast adjustment of the alcohol or OG content. So we have here a multi-step controllers that work together to get a very quick adjustment. Here we see the corosys blending and carbonization system. As I said, often the blending comes with the carbonation because you need to carbonate at least the water part you blend. And so you see here is the injector. The CO2 is distributed here via this control valve. To get the pressure in this solving pipe, we have here a pump, and here we have a control valve to ensure that we have the minimum pressure we need to get all CO2 dissolved at this time. At the end of the dissolving pipe, we have the instruments from Anton Paar. It's the alcohol or OG measurement, CO2 measurement, and as an option, the O2 measurement, and of course also pressure measurement that we can control the pressure. Second part here is the blending part. See the two control valves. So the water is just dosed here right before the pump, and we have also the advantage that the pump will also mix the beer and the water properly. So a couple of seconds later, when the beer arrives here at the inline measurement, it will be mixed properly, CO2 will be solved, so everything is okay for a proper measurement. Talking about cleaning of the injector, you can see here the bypass for cleaning, and here we also use the Venturi effect of the injector. So we ensure that by opening this valve, we have also a sufficient stream of the cleaning media through the inlet of the CO2. So all parts of the injector will be flushed and cleaned properly. Yeah.
Okay, so as Jan explained, most of our systems are built on as units, as pre-manufactured design units. However, the design can change by the customer's demand. So here's an application example from one of our customers in the United States, big craft beer brewery, very known, Avery Brewing, Boulder, Colorado. And actually our very first customer in the United States. So Avery came to us asking, hey, is it possible to have the carbonator running after our centrifuge, but actually don't use the buffer tank? So little explanation what is happening during, so when you centrifuge your beer, there's always this dispensing stop, so where the solids go to the drain. And this actually means the beer flow will stop suddenly. And suddenly means just from one to the other moment, which will also result in having no flow within the carbonator. Without flow, you won't have any carbonation effect because the Venturi tube won't work, of course. So without any Venturi effect, you can't dissolve your CO2. So what are you doing? So we are using our controls. So we are using the accurate and very fast control here, and also added with a recirculation loop. So the beer will recirculate within the system as long as the centrifuge restarts. Once the centrifuge has stopped, the carbonator will also stop. That works with signal exchange and smart controls within both systems. So, and that's the big challenge here. So you want to make sure that all the CO2 stays in solution and is accurately dosed while the whole system comes back up, while the flow develops back again. So, and with fine tuning and fine controls, fine measuring, of course, you are able to do that. You will end up in the packaging tank, in the bright beer tank, without using an extra buffer tank, and the CO2 will be right in spec and the beer is ready for packaging. Means you are saving time, you are saving time to prepare the unnecessary buffer tank. You don't have to clean that buffer tank. You will also save carbonation demand in comparison with carb stones, for example, or any other not efficient method to carbonate. And at some point, for those guys out there who are dry hopping, there is a certain peak where you can save on hop aroma, of course, because you don't strip that much out in your bright beer tank with using carb stones. For the blending, we will see an example calculation right here. So the correction of original gravity, as an example here, just by 0.2 degrees Plato from 12.7 to 12.5. That results in a correction value of just 1.5%, just mentioned. I mean, you can make your own calculation how much that is of annual output, and that's directly raw material saving and capacity increase for free, so to say. It's time saving as well, as you don't have to re-dilute in your bright beer tanks or make any mix calculations first and pump it all around your tank. And of course, it's easy handling. You type in what you want into the system and it brings you there, as well as with the carbonation. Last but not least, constant quality. As mentioned before, you are probably facing problems with taxes because of bringing in beer with higher alcohol, or having to put lots of efforts in order to bring it down. So this system will help you to make it just right from the first shot. Yeah, so this was it from our side. We are looking into questions. Let's see if there are some. Q&A. So not yet, but I can bring in some from my experience. There is a frequently asked question about the system is usually, can I dissolve other gases than CO2 with such system or the injector nozzle? Yes, of course you can, as long as the gas has some solubility in water. That's a possibility. So common use is, for the brewers out there, would be wort aeration. The other one is nitrogen for just stout beers or so on. And it's also working in combination with the gas. And yes, a benefit always is if this gas is detectable. So nitrogen, there is a solubility, there's some solubility, and there's also a way to measure the quantity for it. Okay, let's check back in for questions. Yeah. Oh, so the question is how many systems are running? So in the market there are, so together carbonation and blending, over 150 in the entire world for all different sizes, from a very small craft brewery to the largest brewing plant in the entire world. Okay. All right. So thanks for joining in. Please tell us your opinion. We will offer it in the chat or after the meeting, after the Zoom. It's going to be a Zoom survey, so please fill it out. Help us to improve, because our next Bevinar is going to happen next month. Please stay tuned for the date. We will publish it on our website and the other channels. The topic is going to be water deaeration. So if you like it, please tell your friends, recommend us, and we are all wishing you a great rest of your day. Take care. Bye-bye.
Bye.